This photo cost $700 million. NASA took it in 2015. 9 years after they erased Pluto from the map. You don't spend $700 on something that doesn't matter. So what did they find? August 24, 2006. Prague. 424 astronomers raised their hands. And Pluto, the planet on every classroom poster since 1930, was erased. Not destroyed, reclassified. The IAU called it a dwarf planet. 76 years of textbooks, wrong overnight. And your tax dollars were already funding the mission to go there. The people who made that call represented less than 5% of the world's professional astronomers. The other 95% were not in the room. The most famous demotion in science history was decided by a group smaller than your high school graduating class. One vote, no global survey, no public debate, just 424 hands in a conference room in Prague. But here's what they didn't tell your science teacher about the rule they actually used to pull the trigger. The IAU gave Pluto 3 tests. Orbits the sun. Check. Gravity enough to form a sphere. Check. Third test. Clears its orbital neighborhood. That's where Pluto failed. Too much Kuiper Belt debris sharing its zone. Rule broken. Planet status revoked. Pause on this size comparison for 2 seconds. But here is where the rule starts breaking down. Earth shares its orbital zone too, with asteroids, with near-Earth objects, with debris catalogs that NASA still updates today. Planetary scientist Stephen Soter calculated in the Astronomical Journal in 2006 that Earth scores significantly higher on orbital clearing than Pluto. But the methodology of that scoring has been openly contested by researchers ever since. And then there is Ceres, the largest object in the asteroid belt discovered in 1801, failed the exact same orbital clearing test in the exact same 2006 vote. No $700 million mission launched for Ceres. No presidential coverage. No national conversation. So, if Pluto and Ceres both failed the identical rule in the identical vote, why did only one of them get $700 million and a decade-long journey? That question does not have a clean answer. But the photos from 2015 make it even harder to ignore. July 14, 2015. New Horizons reaches Pluto after 9 years, crossing 3 billion miles of deep space. And what it sends back does not look like a dead world nobody needed to visit. Tumba Regio, a nitrogen ice, plane the size of Texas, shaped like a heart, sitting dead center on a world they called irrelevant. 11,000-foot mountains built from water ice, geologically younger than the Rocky Mountains, meaning something was actively reshaping this surface in relatively recent planetary history. Nitrogen glaciers flowing across the terrain in real time, a blue-tinted atmosphere, layered and complex, reacting to solar wind in ways scientists at Johns Hopkins Applied Physics Laboratory are still publishing research on today. And beneath the surface, early data suggests possibility of a liquid water layer which is the single condition scientists look for when asking whether a world could support life. 3 full seconds. Just the heart photo. No text, no voice. This is not a dead rock. This is a geologically active world with mountains, glaciers, a blue atmosphere, and subsurface chemistry that is still being studied a decade after flyby. NASA's own researchers described it as one of the most scientifically fixed, surprising objects ever visited. So why did the institution spend 9 years and $700 million of your dollars flying to something they officially stripped of planetary status 9 years earlier? The answer is in the launch date, and once you see it, you cannot unsee it. New Horizons launched January 19, 2006. Pluto was demoted August 24, 2006, 7 months later. The spacecraft was already traveling through space when the vote happened. Hold on the timeline graphic. Both dates, 2 full seconds. The mission was approved by NASA in 2001. The scientific case that justified $700 million in federal funding was built across years of research before a single bolt was fitted to that spacecraft. You do not get that budget approved without already knowing the destination is scientifically worth it. You do not build the hardware, run the launch, and commit 9 years of mission operations to a target without the data already telling you something significant is waiting there. And then, 7 months after launch, the institution that funded the trip officially told the public that the destination did not qualify as a real planet. Launch first, demote second, 7 months apart. So, the question is not whether NASA knew Pluto was worth visiting in 2006. The question is, what exactly did they know that made them launch before the public vote even happened? Stay with me here, because this next part is the one NASA has never publicly addressed directly. Alan Stern is a planetary scientist with a career built inside the institution. He is the principal investigator of the New Horizons mission, the man NASA selected, funded, and trusted to lead the $700 million journey to Pluto across 9 years of deep space travel. His public position on the IAU definition that demoted Pluto is part of the scientific record. The orbital clearing criterion is not grounded in physical science. He has stated the definition is fundamentally flawed, and that by its own logic, Earth itself would not qualify as a planet if placed in Pluto's orbital position. Cut to black. Half second. The scientist NASA hired to visit Pluto does not accept the rule NASA used to fire it. The vote was made by less than 5% of the global astronomy community. The images show active geology, a blue atmosphere, and subsurface chemistry. And the mission launched 7 months before the demotion. So, who really fired Pluto, and what is the institution still not explaining? Comment yes if you think Pluto is a planet. NASA reads these comments, and after everything you just saw, maybe it is time they ran the vote again.